Go.
Today's TVs, radios, computers are all ran by microchips. Now, they make our electronics faster, smaller, a lot better than what they had in the days when we used vacuum tubes. And one of the biggest problems with that is electrostatic discharge. Okay, electrostatic discharge is, like it says right here, electrostatic is static electricity, and discharge is the rapid spontaneous transfer of electrostatic charge induced by a high electronic or electrostatic field. What that means is the smaller the component, the more susceptible it is to small charges that you might have as a person rubbing your feet on the ground, or things such as touching things and touching conductive materials and then going and touching your electronics. Tonight I'd like to show you or go through some of the things that might mitigate that and some of the issues that is caused by electrostatic discharge. Alright. The purpose of mitigating electrostatic discharge is to prevent or minimize static generation, prevent static charge items from contacting sensitive items such as your microchips or your resistors that you might have on a circuit board within your TV or your computer or your radio. Safely discharge accidentally charged items, quickly neutralize static sources that can be eliminated, protect sensitive items using packaging, and include EOS from product or production equipment, which is elimination of static discharging. Okay, so most of you might know or might seen pictures of a person going up to a gas station, getting out of the car and going to go pump gas, and the pump catching on fire. That is a prime example of electrostatic discharge. Okay, electrostatic discharge can come from you rubbing your feet on the rug, as I said before, and stepping out without grounding yourself, and then touching a conductive surface like your car. Okay, this is the example of a circuit board. This is the before picture of how it looks before and after electrostatic discharge has hit it. Okay, so you might think just picking up a regular circuit board that you see out of your computer or out of your radio, you might pick it up, you might think nothing will happen to it. But if you were to look under a microscope and see, sometimes this can happen. Okay, these are some examples of the voltage that you would discharge in certain conditions if you were to touch it, such as walking on the ESD floor, which is a electrostatic protective floor. At a humidity level of 25%, you could get 1200 volts just from walking on it. At 55% humidity, you get 300 volts. Okay, walking on carpet, as you can see, 35,000 volts just from walking across the carpet. Would you have higher humidity, 7,500 volts, and so on and so on. Okay. These are some of the parts that are what we call electrostatic sensitive, such as, like I said before, microchips, circuit boards, resistors on circuit boards, and your microprocessors on circuit boards. Any component, part, assembly, slice, unit, or finished product which is ESD sensitive shall be called ESD sensitive item. Okay, if you look at your packaging when you get it, you usually will see a sticker on it that says ESD sensitive. This is something for you to know that you need to take special precaution when you're taking this packaging out. Okay. ESD items can be damaged by static potentials of 16,000 volts or less. And like I said, walking across the floor is already 1200 in certain conditions. Okay. These are some of the protective components that we use to stop ESD. Shielding bags, foil bags, smoky bags. You see these a lot when you get components for these things. And this is how it's broken down. As you can see, there's a static disruptive polyester. That's your silver, shiny package. Underneath that, we have metallization, which helps to mitigate the electronics static discharge or static buildup. And then you have the static dissipative polyurethane, which takes away that ESD potential. Okay. These combined with using grounding straps if you're in a manufacturing area, or being cognizant of where you're standing at when you're taking these off, taking the time to make sure you discharge yourself, can help you to protect some of your vital components that you have and help you to enjoy your TVs, your radios, your computers. Okay, and in closing, just a little reminder, if you guys don't know, that's the Hindenburg. A lot of people don't know this, but ESD is what caused the Hindenburg to explode. It was traveling through the air, with a vinyl wrapping for the blimp caused a buildup of electricity. And then once they tried to drop the anchor to the ground, it wasn't grounded and hit the ground. That caused a charge and a spark, and we all know what happened in Hindenburg afterwards. Thank you for my presentation. Enjoy your evening. Bye.